Good morning, good afternoon, Miss Matei, Miss Pavnika will be talking about binomials squared. So, we will try to expand the binomial x plus y squared. X plus y squared can be rewritten as x plus y times x plus y. We know that that basically means finding the area of a square whose length is, how much is the length? Is x plus y, this must be x plus y, and the width is again x plus y, correct?
That's correct.
Good. Now, it seems like I have to use some algebras that I have never seen before. Obviously, what is y squared? Y squared is a square whose side length is 1, not a surprise. But this xy seems new to me. What can you tell me about the length of xy?
Well, XY tile represent the area of Y times X.
So the length of this tile is y, as you can see here, and the width is
X.
there you go, x times y is xy. Good. So let's try to create the area of that rectangle. What do I need here? I have an x times an x. Shouldn't be a surprise that for that that will give me an x squared, correct?
That's correct.
Good. Now, moving on, y times x, that will give me
XY
an xy, so an xy like that. Right.
will fit right there, and then
x times y, that gives me
XY.
xy, okay?
And the last one, you have Y times Y,
Okay,
and that is the little square Y squared.
perfect fit here. Good, perfect. So I know that the answer must be x squared plus, how much is xy times xy?
We have two of these, so
Okay.
it's 2XY and Y squared.
Beautiful, but you know that I always want to see an algebraic approach. So let's do an algebraically. X plus y times x plus y. How much is that? X times x.
X squared.
Okay, exactly the red square over there. X times y.
It's XY.
The gray one. Y times x.
In the alpha order, it's XY again.
Y times y.
Y squared.
The green square over there.
And
So,
simplify.
Simplify like terms, the two gray squares there. So the answer is exactly as I expect. Now, once I have that, can I do the same thing to get x minus y everything squared? My approach should be absolutely the same. X minus y, x minus y. Minus xy here.
And minus XY there. And plus Y squared.
There you go. So
Minus 2XY plus Y squared.
okay, so here you go. You have a summary of these two formulas right here for you. Having said that, let's apply these two formulas until we know them by heart. For example, let's look at example 1, 2a minus 3b everything squared. What should I do here? Does it look like one of my two formulas? Sure it does.
This is John 701.
This is my x, and this is my
Y.
So there you go. The formula that I should be applying is x minus y everything squared, which is first term squared minus 2 times first term times second term plus second term squared. Correct?
That's correct.
Okay, so let's do the same thing.
If I apply the formula, I have 2a, the whole thing squared,
There you go.
minus 2 times
My first term times
and
my
second, so it's 2a 3b plus my second term is 3b, the whole thing squared.
Okay,
Simplify.
let's get rid of this. We already know the formula, so let's see what I get.
4a squared
Yes,
minus 12ab plus 9b squared.
of course you could have expanded by writing 2a minus 3b times 2a minus 3b, but the whole idea is to apply these special product formulas. Okay, one more.
And here is the formula x plus y.
This is my x, this is my y. It's a plus in between, so that tells me I have to use x plus y, everything squared.
Plus 2xy plus y squared.
Okay,
So
so
let's get started. The first term is 1/2 u
1/2 u, everything
squared
squared,
plus 2
2
times first term times second term. So that's the 1/2 u times 2 plus second term squared, so that's 2, and simplify. So that's the 1/4 u squared plus 2u plus 4.
Good. So that's it for today. Thank you, Miss Lavnika.